Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in finding the average of each level in a binary tree. First, let us take an example. In this tree, the average of elements of level 0 is 4. Average of elements in level 1 will be 11 by 2, which is equal to 5.5. And the average of element in level 2 is 15 by 3, which is equal to 5. We assume that we begin with level 0. Now let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 1, to average of levels function. So root will point to 1. We will be using a queue data structure. We push the root node, which is 1, into the queue. Since the queue is not empty, we enter the while loop. Now we compute sum of nodes and count nodes in each level. We have sum and count variables which we initialize to 0. We take another queue temp. Now we enter the inner while loop as the queue is not empty. We take a node n which will point to queue front, so n will point to 1. Next, we pop 1 from the queue. Now we update sum to sum plus n's value, so sum will be equal to 1. We increment count. Next, we will push the left and right children of n into the queue temp. So the left child of 1, which is 2, is enqueued into temp. Now the right child of 1, which is 3, will be enqueued. Now as queue becomes empty, we come out of the inner while loop. Then we make queue equal to temp. Next, we compute sum into 1 by count. So 1 will be printed. As the queue is not empty, we continue with the outer while loop. Now we reinitialize sum and count to 0. We take the temp queue. Since queue is not empty, we enter the inner while loop. Now n will point to 2 and 2 will be dequeued. We update sum to sum plus n's value. So sum will be equal to 2. Count is incremented. Since 2's left and right children are not null, we enqueue the left and right child of 2 into the queue. The left child of 2, which is 4, is enqueued. Then the right child of 2, which is 5, will be enqueued. Since queue is not empty, we dequeue node from the queue and assign it to n. So n will point to 3 and 3 will be dequeued. Next, we update sum. So sum will be equal to 2 plus 3, which is equal to 5. Count will be incremented. Now we push the left and right children of 3 into queue temp. So 6 and 7 will be enqueued. As queue becomes empty, we come out of the inner while loop. Next, we make queue equal to temp. Now we will compute average and print it. So we print 5 into 1 by 2, which is equal to 2.5. Since queue is not empty, we continue with the outer while loop. We reinitialize sum and count to 0. Also, we have the queue temp. As the queue is not empty, we enter the inner while loop and now n will point to 4 and 4 will be dequeued. We update sum to sum plus n. So sum will be equal to 4 and we increment count as well. As node 4 is a leaf node, nothing is enqueued and we continue with the inner while loop. Now n will point to 5 and 5 will be dequeued. We update sum to sum plus n and increment count. Again, as 5 is a leaf node, nothing is enqueued and we continue with the inner while loop. Now n will point to 6 and 6 will be dequeued. We update sum and increment count. Again, as 6 is a leaf node, nothing is enqueued and we continue with the inner while loop. Now n will point to 7 and 7 will be dequeued. We update sum and increment count. Now as q becomes empty, we come out of the inner while loop and we make q point to temp. Finally, we compute average of level 2 and print it. So we print 22 into 1 by 4 which is equal to 5.5. Now q is empty and we come out of the outer while loop. We have the final output. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.